Hello everyone, we're Group 4 and our project is about M5 forecasting accuracy and uncertainty. I will do the first part, the introduction. The background is to predict the Walmart sales. It can be seen as a time series prediction, and it is worth studying for the industries because it can have a better control of the item amount. It usually needs historical data and current features to do the prediction. There are two parts of the M5 forecasting, the accuracy and uncertainty. They share something in common, but they have some differences. For example, the accuracy is to predict each item respectively, and it is more like a point estimation, while the uncertainty is to predict sales with hierarchical features, and it is more like a quantile estimation. Here's the outline of the data set. I'll take the calendar file as example. It contains some important features like event day, snap day, weekday, and by the attribute WM year week, we can join the tables together to have a better understanding of this data set. And in the visualization part, we can see some interesting features of this data set. As you may see, there are 12 hierarchical levels in the data set. And if we aggregate them and present in a figure, we may grasp some general understanding of this data set. For example, in the aggregation level of states, we can see that California is at the most among the 3 states. The other thing is the periodical features. As you may see in the beginning of the year and in the weekend and in the snap days, it usually sells more than the others, while in the event days, it usually sells less than the normal days. And as for the data pre-processing, we mainly deal with these 3 kind of issues, and I will take the missing values as example. We average the values just before, after these missing values and fill in the main values so that we can smooth it, or we can, that's how we deal with these missing values, right?
Now, let me introduce the method and the result of accuracy part in our project. Since the goal of this project is to predict the future sales, and there are many features showing impact to the sales, we choose LightGBM, a powerful regression model, to train this large amount of data and do the prediction. LightGBM is an improved and faster version of GBDT. GBDT's code is shown as figure. On GBDT space, LightGBM use goals to obtain more accurate results and use EFE to minimize the conflict ratio. In the actual model training and testing, in order to predict the sales data from day 1942 to 1969, we use data from day 1 to day 1941 and put them into the model for training. The evaluation is based on the RMSSE between the true value and prediction value. Our final private score is 0.62812. Now it's time to introduce the method of uncertainty part in our project. All the regression analyze functions mentioned are essentially a conditional expectation function. But more often, we don't want to just study the expectation of y, but also to explore the conflict distribution of y. Or maybe in some cases, we prefer to know a quantile of y. The quantile loss differs depending on different quantile. For higher quantiles, more negative errors are penalized, and for lower quantiles, more positive errors are penalized. Due to the time periodic data, we consider using artificial neural network and LSTM. Their general structure is shown in the figure. We consider directly using the basic neural network to predict the future sales situation and make the uncertainty estimates first. For quantile regression, we set a special loss function. We input the pre-processed training data into the model for training. Among them, each line of training data includes sales data information under a specific hierarchy. Then, for different quantiles, we use the trained model to predict respectively and save it to the submission field.
Since the goal is to predict the sales in the future 28 days, which are time series data, LSTM could be utilized to deal with this kind of task. The input of the model is the sales in 14 days, and the output is the sales of the next 1 day. We are given data from day 1 to day 1913, and the goal is to predict the sales in the day 1914 to day 1941. Thus, the training set contains 1,899 samples, and for each training sample, it contains 14 days sales. Besides, the other features such as the calendar-related attributes are also utilized. The neural network is constructed like this. The input is the sales data concatenate with some embedded categorical features. Then 2 LSTM layers are utilized, and after one dense layer, the output value is the quantile prediction. Besides, we also tried a naive method from point estimation to interval prediction. In M5 accuracy computation, the sales for each item are estimated. In the uncertainty computation, the previous estimation could be utilized to do the range prediction. Actually, the 0.5 quantile is exactly what we had estimated in accuracy computation. We assume it is a normal distribution with the 0.5 quantile as the mean value, and the other 8 quantiles can be estimated. In our project, SciPy toolkit is utilized to calculate the corresponding quantiles. In this part, I'm going to introduce our results. We submit the results of these 3 methods to Kaggle, and the computation uses weighted scaled pinball laws to evaluate our results. Here are our analyses. From accuracy to uncertainty method, since in the accuracy computation, we got good grades by performing LGBM to do the estimation. The uncertainty estimation from accuracy got not bad results too. However, we cannot know the actual variance of the distribution. This kind of method can be a little tricky since we test different parameters to get the best performance. The LSTM with quantile regression method shows the worst results. Some reasons are as followed. Firstly, the loss of periodic feature. Since the input of the model is the sales of 14 consecutive days, which the sales in 15 days estimate is based on. However, although we had taken the calendar-related features into account, but it still loses some periodical characteristics. Secondly, using our prediction cells to do the future predicting, which means the error could be accumulated. Thirdly, model construction problem. It seems some more adjustment of the structure and the parameters should be applied to avoid overfitting problems. The neural networks with quantile regression method, the neural network is fed with a large amount of data with multiple features and time series characteristics. Besides, we added drop-off layers in the network structure to avoid overfitting. It effectively predicts the future sales after iterative training, and it shows the best results among all of the methods. At last, there are some further improvements that can help us to get better performance. Firstly, more feature engineering should be applied. In the future work, we should explore more about the features provided, maybe using better categorical attributes, encoder, or combining different attributes. Secondly, neural network structure adjustment. In the future work, more adjustments of parameters in the neural network structure should be applied to gain a better performance. That's all for our project. Thanks for your listening.